Hi, Nate.
Hey, Tom.
OpenAI's O1 series of models has the same bludgeoning power of Gemini, but its prompts will eviscerate a person just as well as Claude. The O1 models are the most cunning. There's no such thing as outsmarting an O1 model. Dr. Gilbert's Guide to Generative AI, Chapter 1.
I recognize the voice, but I don't know who is on the retort today.
This was a quote from. So my wife and I have been listening to the enhanced audiobooks of the Fourth Wing series by Rebecca Yarros, which are in the genre of romantasy, which is a combination of romance and fantasy. It's basically smut with dragons added to it. But it has all these epigraphs from professors about different kinds of dragons and what their benefits and disadvantages are against each other. And I have weird associations with leaderboard type dynamics from that.
Wow.
Anyway,
Okay.
The voice actor for that professor is amusing to me, and so I wanted to bring that energy into that.
Yes, it was not generated by an AI. If you are listening, welcome to the retort. We have a hopefully interesting debate topic today. We're not going to get bogged down with 2025 is the year of XYZ. We're not going to get nerd sniped by Sam Altman's blog post and on reflections. I mean, the funniest part is him reflecting on getting fired. Obviously, the AGI stuff is a little silly. I've been trying to formulate my ideas around AI for science as an area and kind of trying to understand why there aren't more people that are working in it. What are the kind of trade-offs and risk profiles for it, and kind of the relationship between AI as a scientific endeavor and the history of science and philosophy of science. So I texted Tom over break and I was like, hey, I'm reading the Kuhn Structure of Scientific Revolutions. I'm sure you've probably read this. And then Tom was like, yeah, I wrote a master's thesis on it. So we kind of decided we're going to talk about AI for science and go through these things. I've been reading more on the biological side. I think there's Machines of Love and Grace. Some DeepMind people are obviously very invested in this. They have a lot of projects in this. They have a policy blog where they wrote extensively about the AI for science opportunity. And I think about scientific structures of AI and institutions a lot because AI is becoming more closed. I'll share my kind of reading list for this blog post I'm working on in the show notes. I have a whole bunch of links on AI for science I'm trying to get my head around, but we'll kind of see what we uncover, how AI is emerging. So I don't, Tom, I think the thing to start you on is what do you think that there's two things we should talk about. We should talk about one, why the Kuhn'ian view of paradigms fits so well with what had happened, at least through when the book was written, through the origins of science until the book was written. And then we kind of need to debate how it may or may not apply today with how fast things are moving. So let's start with the old science. I think there's a lot of great, I mean, the book is wonderful. A lot of our audience has surely read it.
It's famous. It's one of the most famous academic books of the past century, I think. It has to be said. It's funny. I can actually get very meta about this because, as you mentioned, I did write a master's thesis that was basically heavily influenced by and riffing on the Kuhn'ian argument about paradigms and paradigm shifts. There's a lot of conversations I've had about this book and its assumptions and argument with people in AI. Going back to my time in my PhD, Michael Dennis, a mutual friend of ours, we had many beers discussing Kuhn and which parts of Kuhn do and don't fit the AI kind of development model, how it works, how it doesn't work, whether it even counts as a science in the Kuhn'ian sense. But yeah, also I happen to, even from my training as a historian, know a fair bit about the origins of the book itself. And so I could talk a bit about what Kuhn's intervention was. If many people are already broadly, just to sort of really, really high level, what is this book? So Thomas Kuhn was a physicist, and while he was, I believe the story was while he was finishing his PhD and transitioning to becoming a member of the Society of Fellows at Harvard, which is a famously like kind of very interdisciplinary, erudite, kind of do whatever you want, intellectually speaking, kind of culture. He became interested in the history of science and trying to explain how physics and why physics has changed so qualitatively over the course of its, from ancient Greece basically to, in his case, would have been like 1940s basically. Uh, Kuhn was influenced a lot in his reading by, actually, the story goes Aristotle. So he started by rereading Aristotle's physics. Aristotle's physics, it's wrong. I'll just say that it's incorrect. Aristotle had a lot of ideas about inertia and mass that are not true, and you can do very basic experiments in your home if you want to see how they're wrong. But they were informed by his ideas about potential and kinetic action and stuff like this. There's a kind of wider philosophy behind it. Anyway, Kuhn, there's a famous story. Kuhn was rereading Aristotle's physics several times and was trying to understand it because it was confusing to him because it was so obviously wrong. And supposedly he said there was a story where he was looking out the window at Harvard Yard while he was reading this book. And he saw like a tree and wind blowing through the leaves of the tree and like the layout of the land, people walking. And I think he may have even seen like somebody like throwing something. And he said that for a split second, he was able to see it as Aristotle would have seen it. What he meant by that was he was able to see the way in which matter was moving, was interacting with other bits of matter, the energy behind it, as Aristotle claimed, for a split second anyway. And he says that this was a key moment in his understanding of what and how physics has changed over time, which is that it always reflects at any given moment a paradigm, as he came to call it. And what he meant by a paradigm was a cohesive set of assumptions, but also practices and habits that are more about, frankly, the psychological state of the physicist than they are about so-called objective properties of matter, independent from the perspective of the physicist. In other words, any claim to objective reality is always conditioned by and filtered through the subjectivity of the scientist in question. In addition to that, Kuhn argued that it's not just a matter of, each scientist has their own subjective interpretation of nature, yada, yada. Kuhn was not skeptical of science in that kind of anarchic way. His argument was more that scientific practice is a community. It's always defined by the norms of some community of scientists, and those norms about what it takes to publish, what it takes to experiment, what it takes to define variables, what it takes to falsify certain outcomes, is a function of those practices rather than a function of objective reality, or in the case of that science, of matter, physical matter. So in the book, and Nate's recently read it, so he probably even can regurgitate this better than I can. But in the book, what he basically says is that means that science, any science, and certainly physics, has qualitatively and fundamentally changed in its outlook and even in what it was trying to explain, what phenomena it even concerned itself with over the course of history. And so if you look at Newton, or you look at Aristotle, or you look at Einstein, or you look at, today, maybe like string theory, it's not just that they represent these kinds of incremental improvements in understanding relative to each other. His argument was that these are different paradigms that are fundamentally incommensurable with each other, where incommensurable just means they can't be measured according to the same standard. String theory is not interested in explaining the same types of things that classical mechanics is interested in explaining. And the same goes for, any one of these paradigms. In terms of how paradigms form and break down, Kuhn basically says a paradigm is a set of practices that define how it is that certain kinds of evidence and conclusions can be brought to bear and accepted by a given community. But paradigms break down when there start to be experiments or there start to be findings from experiments that don't fit according to the assumptions of what people are expecting. The most famous example of this, and I believe Kuhn himself cites it, is the so-called ether theory. So the ether was meant to basically be this material that underlay the cosmos that was responsible for these minute discrepancies in what Newton would have predicted about the motions of the planets. The ether, I believe, was assumed to relate in some way to the propagation of light through the solar system. And so there were a few key experiments, and I believe I'm going to mess up the name of it if I try and name it. I want to say it was Michelson-Morley, but I could be wrong about that. But there was a famous experiment done in the late 19th century to try and determine empirically what the ether was, like how strong it was, where was it. And famously, these experiments found nothing. There was no evidence for anything like this. And this was part of the backdrop to Einstein's formulation of special relativity, which was a complete break from the classical mechanical depiction of, basically like how it is that matter moves as it begins to approach closer to the speed of light. So basically, what Kuhn was showing there was every paradigm defines for itself puzzles that are basically seen as safe within the paradigm. They're open questions, but the idea is that any result of an experiment on that question would not challenge the paradigm. It would just add to evidence. It would just add to the robustness of the paradigm. It's only once experiments are done whose results are not intelligible within the paradigm that there eventually begin to form factions, for lack of a better word, between camps. Those could be between individuals, they could be between universities, they could be between schools, they could be between nation states. It can take lots of different forms that are historically contingent. But the point is, different positions will form that are interpreting the results according to assumptions that were not previously safe or were seen as completely heterodox within the previous paradigm. In other words, the orthodoxy is under threat because it can't continue to reproduce itself in the face of what is now evidentially no longer deniable, right? Eventually, one of those factions, possibly just by brute force, possibly by merging with other factions, it's basically a political struggle. But somehow or other, eventually, a new faction will be able to position itself as the new orthodoxy by mobilizing new assumptions, new kinds of experiments, new kinds of data, new kinds of methods, whatever, new curricula. And also, I should add, a new interpretation of the history of the science itself, right, that culminates in itself. And once it does that, the history of the field is rewritten around that new camp. So every future student, having been trained in that field, will be basically habituated into that new paradigm. And a lot of information has been lost or forgotten as a result. So ironically, most of how paradigms form is by forgetting a lot of what previous paradigms were about, what their goals were, what their assumptions were, and why those assumptions were so strongly held. So zooming out, the reason this book was so influential and so controversial was it was taken as a direct challenge to positivism, to a kind of naive empiricism, which basically argued that just collecting more and more data about the world will tell you more and more about it. It was a challenge to, even in a very broad sense, I think it's fair to say, a certain kind of post-World War II confidence in institutions. Because Kuhn was interpreted as saying that science was not objective. In other words, that science was really in some ways more like an aesthetic practice or a political war rather than science. That's science is just another word for politics, in other words. And the reception of the book over many decades has reflected that. There's a lot more that we could discuss about that. But Kuhn, I'll just finish by saying, Kuhn himself did not see his book or his argument as in any way dismissive of science. He himself was a physicist. He had a PhD in physics. He continued, I believe, to practice research in physics and continued to work on the history of physics after this book, not because he was trying to demolish it, but because he was trying to understand it. And I think Kuhn himself would say he was really just trying to expose the practice of science itself to the kind of investigation that science itself strives for, that we should try and approach science itself scientifically. And what does that mean? It means looking at how it can change over time, different phenomena, conduct experiments, look at it as an empirical phenomenon rather than as some kind of transcendental gateway to absolute truth. I'll pause.
I think a few things that are important. This was published in 1962, so like the 50-year edition, and this has like long been a thing. It's not new, and since then, I think physics has like especially come out of vogue as the de facto like what is like the default scientific area.
Yeah,
and I think there's the hardest thing for people that work in science to understand is how to interpret the positivism. God, I don't know why I'm struggling with this.
Positivism,
positivism is part of this, where it's like accumulating knowledge versus kind of pushing the frontier and what those mean. And I think the analogy for positivism is that you're like filling a known circle of potential knowledge. Whereas if you think about a PhD in the kind of more flexible sense, is that you're just pushing out the frontier of knowledge within some kind of paradigm defining thing, usually. And you can kind of punch the hole through the edge of the paradigm, and then it kind of can cascade into bigger changes. So I think as a scientist, it's kind of nice to reflect on what like these words of accumulating knowledge and standing on the shoulder of giants, etc., actually mean in this context. So that's like kind of the basic scientific reflection. And then all of these things with respect to AI become much more interesting. I go back and forth with whether or not I think AI applies and which like where you would draw the abstraction of the paradigm. I was thinking that like the paradigm now would be essentially like scaling, which is like sufficiently broad that can capture the ideas where it's like most results are defined by the idea of extending compute and data to get better models. Within that, a lot of the analogies break down like the definition of puzzles and the expectation of like whether or not you find knowledge and what a contradiction would look like. So I kind of couldn't flesh out the idea of how to wrap this paradigm around recent AI. And then it would be like pre-scaling deep learning could be a paradigm, and like really pre-deep learning AI could be a paradigm of AI research. But the specifics become interesting.
Yeah, a few things there that are worth picking up on. One is, I guess it's a bit of an ugly truth, but that Kuhn himself was very clear about this. If you're getting a PhD in a field, pretty much by definition, you are not allowed to innovate in a revolutionary way. Because when you're getting a PhD in a field, in a scientific field, overwhelmingly what's happening is you are being socialized into a certain way of interpreting and processing the reality that you're investigating. So anything that you find, anything that you publish, anything you collaborate on with your advisor, almost by definition is going to reinforce an existing paradigm. If it doesn't, you're going to get in trouble. You're going to have a bad day.
I don't think people like intentionally break the paradigm. I think normal PhD students can get results that end up breaking the paradigm, but the institutional pressures are not to design your work to do so.
You can certainly, yeah. I mean, Kuhn's language for this, I'm trying to remember the precise phrase he uses, is that, when you look back at an outdated paradigm and you look at the research that was done, even like every day by its practitioners, often, if you just look at physics, often they would find results all the time that would later be recognized as falsifying the paradigm. Okay, so like, for example, radiation, right, was not recognized for its significance until much, much, much later, well into the 19th century. But superficial or evidence for it had existed for centuries, or in some cases since antiquity, but they were not recognized as such. And even when experiments were conducted that were able to isolate its effects, they were often dismissed as error. And so overwhelmingly what happens is if you do research that is within a paradigm, what you find is overwhelmingly incentivized to be interpreted according to the assumptions of that paradigm, even if it's in fact radically innovative or able to find new information. And so there's this kind of conceptual leap, or maybe it's better to say an interpretive leap, and maybe even better to say a generational leap that almost always accompanies a paradigm shift. A famous example of that in physics is the fact that almost every major innovator of quantum theory it's absurd. I mean, something like 20 years old, like when they were developing some of the most canonical papers. Now, you could argue that the reason for that was that it just so happened that there were a species of super geniuses in continental Europe who came of age basically when they were teenagers and just started writing bangers. Okay, now you could argue that. Kuhn's argument, and there's a famous quote, it's not his, but he made it famous, is that physics advances one funeral at a time. And what he meant by that was the reason they were all 20 years old when they wrote these papers was that nobody older than them would have been caught dead writing those papers, because they were already so committed to the paradigm, either in practice or in theory, that they would have been committing professional suicide to write papers like that. So basically, the field had been constipated for decades and sitting on this kind of potential leap in imagination. But the dam just didn't break until you had a generation of folks willing to do that. Like if you saw the movie Oppenheimer, clearly that guy was brilliant, but he was also basically the same age as these guys, 21 years old when he's in Europe, writing his foundational papers and doing his early work on black hole, entropy kind of stuff. So he was one of those folks.
Yeah. So what do you think this means for AI? I don't dispute any of this. I think the youthful, there's definitely all sorts of hiring or career things where this is actually reflected and people want to hire people that haven't had their moment or whatever. But this is where
it maybe gets into an interesting debate, because I don't actually know where you stand on this, but I can say where I stand on it. Because one important way in which Kuhn's book was controversial, I've named some, but another important way was, to what extent is this really just a story about physics? And is it fair to see physics as emblematic or as the most prestigious or the most fundamental or most emblematic of the sciences, right? And so that's one dimension along which these ideas have percolated subsequently. In my master's thesis, what I did was interview the leading figures of string theory and other competing camps to string theory to basically figure out why it is these camps hated each other, in order to map out what were these different paradigms, what's the state of that war. So that's why I was very directly influenced by Kuhn in that regard. As far as AI goes, my stance on this is I'm not convinced AI is a science. In fact, I'm basically on the record saying it's not, because part of the inspiration for my whole voice on this podcast is that AI is really better approached as alchemy than as science. And what I mean by that, if I can phrase this in Kuhn's language, is that it is a paradigm. I think it's better thought of as an engineering paradigm. Okay. And so its practices are rooted more in the ability to scale engineering projects rather than scientific endeavors. And that the assumptions at the heart of it are better thought of not as scientific principles, but as metaphysical beliefs about rationality, which are not falsifiable and therefore are not able to fit within a scientific worldview. That's a very strong statement. It's one that I think I'm prepared to defend. And I
So this
believe
is
it's
saying that
advancements.
I didn't expect to go 0 to 100 this fast. Is this essentially saying that intelligence is not like a fundamental principle that we can study? If it's around like
Oh,
rationality and stuff like this.
you can study it. I absolutely think you can study it. I think cognitive science is science, for example. I think that the ability, basically, if your goal is to represent the mechanisms for cognition, there is a science for that. And it's called cognitive science. And cognitive science, although it's an interdisciplinary field, I think is a field that has a clear history, a clear set of assumptions, a clear set of methods, and has advanced. Even in the Kuhn'ian sense, I think you would argue that it's matured, and you could map out its history accordingly. So there's that famous diagram of like cognitive science and the different kind of subfields of it. One of them is AI, but then there's also like linguistics, and I think anthropology is one of them. There's a famous diagram that I don't
Like
necessarily
I
endorse
don't
all
know
of
if
it.
this is means that it's restrictive for AI to be operating in this paradigm of science way, more that is like current and moderate term trajectory does not imply that it is in this kind of paradigm form.
Say more about that.
Well, it's like this could be viewed as the first paradigm where where the methods are motivated on, e.g., like rationality or other presumptions about what intelligence is. And then there's a long arc of kind of trying to reconcile that and take it to its end of whatever these current generative AI models are. And eventually, like, there could be an end of that march that looks like rebuilding a whole new set of ideas. Like, there could be a discovery that is unlocked by that, which starts building an entire new method of proceeding with AI, which would look much like it. I think it's like hard to call it it's hard to view something as a paradigm if there aren't obvious segmentations to it. It could be that we're like living in the Newtonian era of physics where it's like this is just the one thing and it's kind of nice and we're going to keep expanding it and we haven't had everything be totally torn down yet. I might not have the right historical analogy. That's just my
I
pushback.
would
I don't really know how I view AI going. Like I don't know if in
it
20 years it'll look very different or not.
it sounds like we may agree, actually, and I'll elucidate why that it feels that way to me. If there was a period of history analogous to kind of like where we are now, yeah, this maybe isn't fair to antiquity, but I'll say it anyway. So the ancient Greeks did in fact invent a lot of sciences, not just one. And and again, not an endorsement because he ended up being the paradigm is out of date. But Aristotle did canonize, I mean, like basically over a dozen sciences, like basically from scratch that we still use: biology, physics. Okay, he made up that word. Lots of other fields, right? Botany. Um, it's truly remarkable the leap of imagination that took. I would describe where we are kind of analogous to where like ancient Rome was, because ancient Rome didn't really add like new sciences. They just sort of bootstrapped a shitload of engineering projects on top of the sciences that the Greeks did and just scaled it like in an enormously impressive way. But it was impressive on a technical level and not really on a conceptual level. So when you think of things like aqueducts, or I don't know if people saw Gladiator 2, but like, the Colosseum, I mean, just the scale of that stuff was new. That just hadn't existed before. And it was transformative. It was transformative for society, it was transformative for culture, it was transformative for how people lived. But it didn't really change anything about, well, I'm asserting this, I guess. It didn't really alter our understanding of reality or a relationship with the cosmos, not just in a physical sense, but in any other scientific way. The knowledge that was added by the Romans was largely technical and procedural and methodological. It didn't really qualitatively shift a paradigm, I would argue, at least not a scientific one. Now, I'll add, though, that I do think, and I believe I've said this maybe even on this podcast already, I'm absolutely sure that what generative AI is doing now is going to it is birthing new new scientific paradigms of social science, of economics, of, cross-national development, certainly of psychological development. I mean, not in ways that are necessarily good, but just we're going to understand much better the science of belief, the science of information, the science of how people process information, because we're now so information saturated and we weren't previously. So all of those
Yeah,
things I think are advancing.
I have more to say on the kind of other fields being advanced into new paradigms. But first, I kind of want to go through that like mental exercise of what the mechanisms that people do science by, and why like AI may or may not fit this. So it's kind of like the puzzle analogy, and then you can accumulate kind of whatever the I don't remember the word he uses, but you can like accumulate disagreements by doing puzzles. But I even think like the idea of
Yeah.
puzzles to like verify theories, there's very few of them in modern AI. I think like a scaling law is one of the few actual like theoretical results that applies to many different domains. But there's not a lot of actual theory underpinning the development. And then the kind of scientific process goes from like using instrumentation to confirm theory, and then you find mistakes. And it's like we're just plugging away with tons of instrumentation, not really based on any specific theory. So without that, that kind of puzzle metaphor from Kuhn and other things have a hard time being built up and applied.
Yeah, I don't think, well, if you were to look at something like von Neumann Morgenstern expected utility theory, or like the theory of rationality that is still heavily influential in the design of rational agents, I don't see those assumptions being, readily falsifiable by any empirical test. They are interpretations of what it means to be a rational agent. If you were to show those assumptions to somebody from pre-modern periods, at least of Western civilization, they would interpret them maybe as philosophy or as political philosophy or as ethical statements, and not as, you know, empirical observations about, what people are or what agents are. The ancients were clear that defining agency was in many ways more of a political project than it was some kind of objective scientific endeavor. Now, I don't mean this to say that it's bullshit. It's just that it's a philosophical stance that many computer scientists, and I should add, maybe more specifically, AI theorists, are committed to, and they are committed to because they believe them. But I don't see any simulations or, scaling experiments or anything like that being able to even reinforce those views beyond the fact of whether you're already committed to them or not. That's why I think at the heart of AI is basically basically a kind of metaphysical or spiritual set of beliefs and commitments that are not really ever intended to be offered up to empirical scrutiny. They're not really ever intended to be tested in the way that would present themselves as puzzles that either do or don't fit within the current paradigm. Now, I do think that's a problem, but I think the nature of that problem is not a scientific one. I think it's largely a matter of contesting what we want agency to mean, what we think agency should or should not look like in order to be efficacious. Um, Now, our language is confused on this because we talk about capabilities, we talk about scaling laws, and we talk about all these things as if they're real. And I'll just say again, like technically, literally speaking, they're not real. They're simulations, right? They're simulated things, and we refer to them using these words, where the words originally are rooted in actual things. And as long as we continue to live in a way that we act as if those simulations have purchase on us, that's a practical commitment. But again, it's not really a scientific one.
Well, I mean, like hardware chips are real things. Like there's bits of electricity moving
Absolutely. Yeah.
around.
Mhm. Well, but I think that's a different, well, okay, I guess scaling laws. I was referring more specifically to, yeah, I guess I'm remembering now. So scaling laws can refer to a few different things. Scaling laws can refer to, they can refer maybe indirectly to Moore's law. They can refer to the way in which data that's just collected, at certain scales is able to improve performance in some exponential way on certain tasks. They can refer to different layers of the stack, in other words. To refer to all of these things as scaling laws is a paradigm. There is a paradigm there, but I would describe it as an engineering paradigm rather than as a scientific one. Like Moore's law is not a scientific law. I think Moore himself understood that. It's
Yeah,
better
it's a
understood as a
decision. Yeah,
it's a
it's
it's a
like a
decision.
sociological decision to keep scaling these things.
It's an observation about the market dynamics of
Okay,
transistors.
so I have a proposal that maybe more classically scientific fields are going to reduce into this as well. Because essentially, if AI is starting a new paradigm in these and they're computationally driven, the pace of progress in meaningful breakthroughs is going to be faster than the historical institutions can actually adapt to them. So, like, if you have a PhD level thing that, or like something that could do a PhD's worth of knowledge in 2 months computationally in some economics field, like that doesn't fit within the existing structures of peer review, degree setting, just like
Yeah.
how ideas emerge. So I'm wondering if this kind of view of paradigm only works in a world where things are moving slow, like quote unquote slowly, and there might be kind of entirely new feedback mechanisms. And I don't know if this going faster will make ideas like make it so there are more paradigms emerging at once. Like there's no time to settle all of the conflict. Like there might be more noise just by the ability to create results faster. I I don't. I'm not a philosopher of science, but I can just see how like other fields get this curse or blessing to be more like how AI is proceeding.
It's a great question. It's something I've thought about. I can try and think out loud about it right now because I think it's an urgent question. It's an important question. On the one hand, you and I, we already kind of shit talked the Nobel Prize stuff that happened. Uh, God, was that just last month? It actually wasn't as long
It was
ago
a
as I
few
guess.
months ago, I
Is
think.
it okay? Yeah, Jeff Hinton, and then also the protein folding stuff. I I remember at the time feeling that Jeff Hinton's award was more unwarranted and egregious than the protein folding one. And the difference for me, I'm just speaking for myself here, but the reason is related to what we're discussing, which is the protein folding work from DeepMind. It really did exponentially speed up certain parts of a scientific paradigm with a capital S, namely, like the parts of biology that were relevant to predicting and understanding the structure of proteins. It really did, from what I understand. I'm not an expert in the field, but from
Yeah, I
everything
have
I've
a
seen,
specific. I have converged on a specific point on this, which is that um, AI for large AI for science projects can give ultimately ridiculous results that like immediately shift paradigms. So if you like, given that like AI is still early, DeepMind can spend a ton of money using AI as a super powerful tool with scientists to kind of like jolt a huge amount, like a large amount of progress, which in the Kuhn'ian sense just kind of like zaps it into much more likelihood of like a paradigm shifting type of thing. And then there's generally that AI will help science, which is kind of like this thing where I was saying if you have an economics student can do their PhD in 2 months type of stuff. So those are the kind of two things that I see as separate. And it should
yeah, I mean,
inform some of this.
there is precedent for this. So I don't know if Kuhn himself gave this example, but and this is a bit of a cheeky way of putting it, but I think it's still basically true. You could cynically interpret what Galileo did as he just took a microscope, which they already existed, they were already in use. He just turned it upside down and pointed it at the sky and started discovering shit. Oh,
Yeah.
look at this. Jupiter has more moons than we thought. Oh, look at this. The moons are imperfect. They have craters. Oh, look at this. Heliocentrism is probably right. Like just dropping bangers left and right. And on some level, all he did was just be a better empiricist. But he did it by transforming the paradigm. He transformed the practice because he conditioned it on a new tool. And I do think it's fair that there will be, and already are, lots of scientific paradigms or fields that are being transformed by the application of AI to longstanding problems, if only because it so thoroughly speeds up the rate of discovery and progress that it, in effect, transforms the relationship of scientists to their own practice. That's I think the side of the innovation there. Now, there's another side of it, which you kind of mentioned, which is whether a rising tide lifts all boats here. Like, is every scientific field or every paradigm that already exists eventually going to be just sort of hooked in to data analytics and predictive, like all this shit? I don't think the answer is yes. I think the answer is no. And I think that's important from a Kuhn'ian standpoint, because Kuhn's argument is basically that what science is fundamentally is a certain kind of contingent, malleable, but institutionalized relationship between scientists and their objects of inquiry. That there's some dyad, there's some polarity between the subjectivity of the scientist and the objectivity of what it is they're trying to study that defines scientific practice. And the size of that dyad, the intensity of it, the speed of it, the scale of it, by definition, is distinct for different sciences. And there are certain sciences which are relatively far removed, I think, from what the current generative AI wave can provide to alter that dynamic, or what they aim to study will itself be like transformed just by generative AI, not because generative AI improves it, because generative AI's applications become part of what they're studying. And so there's a whole side, I think, of you mentioned the economics PhD student who finishes a PhD in what, 2 years or something. It's like, sure, but then what if you want to study the economic impacts of generative AI, right? Then that would be a different
Oh
kind of
yeah, I
argument.
certainly
And
agree. I think it's a
yeah,
subset of fields. I think it's like a fork where it's like some percentage gets sucked into the gravity well of computational research, and the others are just there, or there's like a distribution on how much they're impacted. You could definitely see many different distributions of what is or is not impacted. Like gravitational wave research, probably pretty hard. You still just have to build gigantic like antennas in the middle of the desert. I don't think they're gonna like they can analyze their data faster, but I don't think the fundamentals are going to change that much. Versus like AlphaFold, protein folding, DNA sequencing type things.
the side of a critique of Kuhn here that I'm more interested in is, not just kind of gaming out when or whether certain scientific paradigms will, or to what degree they'll be disrupted by this technology. It's more, I guess it's a little bit deeper. It's more like Kuhn's argument and a lot of one dimension along which he was attacked. Kuhn is still assuming that science is really about trying to discover what nature is, regardless of people. That's the objectivity side of it. There's still this idea that any science, no matter what it's trying to study, is ultimately interested in this kind of unchanging, totalizing, systematic, internally consistent, but also endlessly verifiable representation or correspondence with anything that's out there. And my sense, this is a theme of a lot of our episodes, I've kind of alluded to this. My sense is that a lot of people in AI who are pushing the envelope of AI really just don't care about representing reality on its own terms. They're much more interested in disrupting it. They're much more interested in changing the conditions under which we live, changing practices. And so that is transformative, but it's not transformative in a Kuhn'ian way so much as it's demolishing the Kuhn'ian idea of what science is really always striving to do. If we're more interested, again, social media is like always the kind of thing in the back of my head about this. Social media is an opportunity to do lots of new kinds of experiments on how people make meaning, process information, you know, meta level cognition across civilizations or across nation states. Like you can actually do experiments on this now, thanks to that data, assuming some measure of openness, which the companies may or may not be willing to provide. But in theory, the data is there now, and the methods are maturing to do it. But in a way, though, that's not really the point. The point is to connect people in ways that they previously just were never connected. And so if there's new sciences and new paradigms that are going to fall out of this infrastructure, that's still downstream of the fact that we're just going to live differently than we ever did before. And so that's a deeper cut that's more, again, more metaphysical than scientific, because the goal is really more to change the nature of the thing that you're studying rather than to just study it on its own terms. I'm curious to hear your reaction to that, because I think this is important, and I feel like you're maybe different than other people in AI because you even care about like improving or, otherwise augmenting our knowledge of people rather than just changing people to make them easier to know.
Yeah, it's really a sociological question on like how true, like what the true meaning of being like AGI pilled is, and like trying to create a powerful entity. Like I think a lot of it actually reduces. I think most people really are just enjoying the rush of finding new things really fast and building things that are useful. I don't think most people are actually malicious of like, oh, I want to disrupt power structures by building AGI. I think it's just fun to build new things and to do stuff, and then a lot of just capitalism kind of takes it along its natural path. Like we're locked in for capitalistic reasons. That's not to say that I think that aren't people that are like actually thinking that AGI is something they need to get because it's going to help restructure society and stuff like this. I just think it's easy to apply the lens of a few crazy apples to everybody that works in the same company or something like that. Like I think the normal people are not doing anything particularly crazy. They're working on technological revolutions have come before. I think that it's fun to work on things that are changing fast for many obvious reasons. It's just like it's exciting.
Another parallel here would be to, and I don't recall what Kuhn himself ever wrote about it, but I think the moment we're living in is transformative, and it will be looked back upon as like, I'm not in any way denigrating like what's being done. If anything, I'm kind of meaning to elevate it higher. I mean, this is really kind of more like the Industrial Revolution, I think, what we're living through. The Industrial Revolution in the Kuhn'ian story, I don't think was directly correlated with any particular scientific revolution. It happened after Newton, for example. It happened in parallel with a lot of chemical discoveries in chemistry, and really the kind of final divestment of chemistry from alchemy. And that was very important. But it really was just James Watt helping people understand that steam can be basically infinitely leveraged to produce power and work. And people were like, oh shit, that can get crap done quickly. And people just rode that wave, for a long ass time. And so there were a lot of scientific implications of that, but they were kind of random. They were kind of idiosyncratic, and they weren't the point. The point was economic. The point was demographic. And the point was developmental, societally speaking. It wasn't, the science stuff was involved, but it was frankly secondary, like very secondary. And again, the Nobel stuff, that didn't start until like 100 years after what we're talking about. Like that was a much later development. And so, I'm reminded of this famous quote that I believe comes from Archimedes, where Archimedes had a similar kind of moment where he was like realizing levers, like literally levers, like what those could do physically, depending on the fulcrum and stuff like that. And he said famously to his lab one day in their lab meeting, he was like, give me a lever long enough and I could move the world. put the world on one side of it. And one of his students
I mean,
one of his
yeah,
students
you need the
supposedly
right power
responded.
fulcrum.
One of his students supposedly responded saying, "Yeah, but then where would you be?" and I think he meant that, what was meant by that was not just physically speaking, where would you be, but like existentially speaking, where would you be, right? Like you'd have to be outside of the entire world that you're trying to move. And that doesn't make any sense if we're still living in whatever year we're living in. And so that's, I think, still how I think about the AGI stuff. I'm not a critique of AGI because I don't think that we're going to have absolute transformative capabilities that in many ways are comparable or surpassing human cognition in any number of domains. That's not the point. The point is, I don't see a way to build it. I don't see a way to deploy it. I don't see a way to test it. I don't see a way to integrate it that doesn't fundamentally remake the conditions under which any behavior is intelligible. And so it's not just.
I mean, this is why a lot of people are raising the alarm bells. That's why there's like a lot of alarm bells in it. Even like AI safe. Some people that are roped in like AI existential risk are motivated for that reason, which is just like this wave we are on is now pretty much unstoppable. I mean, if as long as it crests soon enough, like it's economically unstoppable. And it hurts to tell people that aren't like, how do you tell somebody who's not following AI that there's this thing that's ticking and in a few years it is going to disrupt your life and we don't know how? Like, it is not an easy communications problem.
The ugly truth here, again, is that we're not living in a world that is governed by the norms of science. We're living in a world that is governed by the norms of capital investment. Once capital became luridly fascinated by AGI and, by extension, just, computation and everything that can unlock, yeah, we're in a path-dependent journey towards some point of abstraction. We call it AGI, but honestly, we don't really know what it is. I'm not sure AGI is actually a sufficiently ambitious word to describe what that is. Because AGI has this scientific pretension of saying, like, well, whatever we're headed towards is like going to be mechanistically on a par or beyond, like what we mean by human intelligence.
Just describe it as the like full rendition of our digitalization of the society and world. It is the final form.
But
is
AGI even the right term to describe that?
I don't think the AGI term means anything.
People still act like it. It seems to mean so many different things to different folks.
Yeah, it's a meme.
So I hope that I don't know what that end point is that we're headed towards, but whatever it is determined by the logic of capital and not the logic of science. And so I think there's limits to what you can do with Kuhn if what you're trying to understand is where we're headed at a civilization or a societal level.
Yeah, that makes sense. So hopefully that's not too gloomy for people. But it's a good.
Yeah, it's sobering. I don't mean it to be gloomy. In many ways, it's actually quite exciting.
It is
because we don't know.
It's very emotional and inductive of a lot of things to wonder about.
Any other bases we want to cover? This was a pretty rich conversation.
No, I think I'm mostly good. We'll see when I get to actually writing this up. It's kind of a mouthful to try to write clearly.
Well, I'll be interested to see what form that takes. And yeah, we'll be in touch.
Yeah, sounds good.
All right.
Good luck with everything else. See ya.